Hi, Professor Chen. This is my second video for the last homework, and this video is about question 2. And the question is, it is suggested that the following function of v, these three functions here, may represent an autocorrelation function of a WSS stochastic process by setting v equal to tau, or a spectral density function by setting v equal to omega, or both. And we need to identify which function fv may represent either or both and explain your answer. And in order to identify which functions can represent an autocorrelation function or spectral density function or both, we need to recall the properties these two functions have. And R tau autocorrelation function has properties like this. And the first one, R0 is equal to the EST squared, which means it's greater or equal to 0. And the second is for a real WSS function, the R tau is an even function, which means R tau equal to the R minus tau. And the third one is R0 is greater than the absolute value of R tau here. And the fourth one, which is most important one, is the S omega, which is the power spectral density function corresponding to specific R tau, and it is the Fourier transform of R tau is greater or equal to 0. And S omega has properties. The first is S omega is greater or equal to 0, and the second one is S omega is even function. And we use these properties to identify which fv can represent either or both. And the first function is here is like this: fv equal to the e to the minus absolute value of v, and f0 is equal to 1, which is greater than 0. And fv is equal to the f minus v with the absolute value of v, which is currently the fv is an even function. And fv is less or equal to the f0, which means when v not equal to 0, it's less than f0. And so the former three properties the fv can satisfy. And the last one, we need a Fourier transform of fv to find its corresponding power spectral density function here. And we can find that the Fourier transform of fv is equal to this, which apparently is non-negative, so the fv can represent the autocorrelation function R tau. And we've already showed that the fv is an even function, and apparently with the absolute value of v in fv, apparently the fv is non-negative also. So the fv can represent the S omega too. So the first fv can represent both. And the second one is this. The second fv is this, and the f0 is equal to 1, which is like this. And the fv is with the square here, and fv is of course an even function here. And we know that the fv is equal to the sine v squared then divided by the v squared. So apparently the fv is less or equal to the f0. So and the first properties, we need to Fourier transform of fv. We can find that its corresponding power spectral density function is like this, and we can find that this is non-negative function, so the fv can represent R tau here. And S omega has properties, and S omega greater or equal to 0, and S omega is the even function. And just like the first question, we already proved that fv is even function. And what's more, with sine squared v and v squared, f is apparently non-negative function here, so the f can represent the s omega 2. So the second function can be represented as both. And the last one is like this: f equal to 1 when absolute value of v less or equal to the alpha, and f equal to 0 when absolute value of v is greater than alpha. And we can realize that apparently the f is an even function, and f0 is equal to 1, which is greater than 0, and f is less or equal to f0 here, which is apparently these two properties f can satisfy. But when we Fourier transform of this function here, we realize that it's equal to alpha multiplied the sine alpha omega divided by 2, which apparently this is not non-negative function, so the f cannot represent r tau here. Even though even though the former three properties f can satisfy, but the fourth one it cannot be satisfied. And f is apparently greater or equal to 0, because f can only equal to the two values 1 and 0, so the f can represent the s omega. So in general, the first two functions can represent both, but the third one can only represent the s omega here. That's all.